So for today's problem, I want you to go and read this carefully and just think about this, okay? I want you to at least give me your best estimate to how long it'll take these people to work together. So here's the prompt. A file clerk needs 6 hours to file an average day's paperwork. 6 hours. It takes a trainee, which is like not a professional, just fresh out of college and just joined this company, right? To do that same job, it takes that trainee 12 hours. So you kind of see that the professional can do it half of the time. How long would it take if they work together to complete that same task? I want you to think about it and then give me an estimate of time for them to work together. So go ahead.
9.
Yeah.
Well, just go ahead and
9 hours.
just estimate it.
It's 9 hours.
10 hours.
All right, so as we look at this one last time, remember the clerk, the professional here, takes only 6 hours. And with the trainee's help, you should be able to say that, hey, if that person working by himself professionally takes only 6 hours, but with the extra help, it should be less than 6 hours. And that's what the goal is. We want to have an answer that's actually less than 6 hours to say that it's correct. If we have anything more than that, it doesn't sound reasonable. And so we'll definitely go back to this problem again, but before we can actually work on this problem, I want you to introduce a concept of work. And to do something like that, we are actually using ratio this time. You guys still remember what ratio is?
Yes.
What is it?
Ratio is like, what's it called? A number over a number. Maybe
It's comparisons, right?
Yeah.
If you want to say that. The number to number, so basically it's a comparison between two units, right? So think about this. What's involved here? If you read this here, it's involved a person doing some kind of task. And how long it would take to do that task. Is that correct?
Yes.
So now if you have to write it as a ratio, don't we just have this? That you are actually talking about some kind of job, comparing that to how long it will take to do that job. Task versus time. Right? You see? So that's the ratio that we're talking about today. We are working about this, and this concept is called work. How long will it take you to do that task? Work. Okay? So let's go back and revisit the clerk again. For that clerk, how long did it take the clerk to finish one task?
6 hours.
6 hours. Okay? What can you say about the clerk again? How long did it take the
6
clerk to do?
hours.
Oh, so look, if we're going to do it as a ratio, wouldn't you say that for one task, which is filing paper, right? So for one task, he does it in 6 hours. So this is the one job that he did. So here's the job, and here's the time that it took him, right? One job, 6 hours. Okay, that's the clerk, the professional. Now, the apprentice, or the trainee. The trainee here, how long did it take the trainee to do it?
12 hours.
Oh, it's for that same job, right?
Yeah.
So that same job, that one job, that training will take 12 hours. Is that correct? And what was that last question?
How would it take to do all together?
All together. Now, wait, let's add. Interesting. Together in math means add, right? So we know that we want them to join force, so we're adding them. And the question now is, how long will it take them both to work that same job, which is only one job, right? Not 2 or 3 or 4. That same job, how long will it take them to work together? Do we know how long it will take them yet? No, so we don't. What do we put here? X. And so what does X represent?
Work. Hours.
Hours for what?
They work together.
Time working together, right? So my suggestions is when you read that problem, declare the variable ahead of time, saying that, oh, what does X represent in this case? So that when you are done declaring, you know exactly where to put your X. So guess what? We just formed an equation. So let's take a look. Let's clear up the units here. So this is 1/6, this is 1/12, and this is 1 over X. Does that remind you of yesterday now?
Yes.
It is an equation. So what do I have to find first? Yeah, well, okay. What's the LCD? 12, just 12? 12x, because there's an x here too, right? If you just do this first, the LCD is 12. Is that correct? But don't forget there's an x here too that we need to find, so if you do the ladder on it, there's nothing to take out. except for 1, so therefore it's just a product of everything. So 12x is our LCD. Now let's go back and see this. If 12x is our LCD, that means we do what to every single term? Multiply. So here's 12x, here's 12x, and here is 12x. What get canceled?
Those two.
Which is what? What would you get?
6 and 12x.
Which is?
2x.
2x, okay. Multiply by 1, get 2x. And over here?
X.
Just x. And this one?
12.
Just 12. Oh, this now is a very simple problem to see. 2x plus x? 3x equals to 12. And how do we solve for x? Divided by 3. X is 4 what? Hours. Oh, that makes sense.
I knew it would be that.
For the clerk, that same job takes them 6 hours. For the trainee, that same job takes that trainee 12 hours. Together, 4 hours. That's make perfect sense, right? Because he's getting extra help, and so therefore it should they should be able to get the job done a lot faster.
I was close.
Okay. For those who got like 3 or whatever, yeah, he came close, but at least you understand that, hey, this is what I'm looking for. This is that kind of answer, that ideal answer anyway, before you start solving for the problem. Okay, now that you understand the concept of work, notice that's the structure that we have to go through. We are setting it up as a comparison, ratio in this case. We are comparing the job versus time. Job on top, times on the bottom, right? And whatever information we have to fill in, but don't forget to declare your variable as well. So as you look through this problem, hopefully you can actually tell me, oh, come on, we'll get it. Moving on. All right, here we go. Working alone. Ryan can dig a hole in 5 hours. Castell can dig that same, or do that same job in 6 hours. How long would it take them to work together? Can you set this up?
Yeah.
What do you declare first?
The
The variable. Okay, so what do you say?
X is the
Time.
Time working together, okay? Some time working together. So I'm going to go and give you some time now to work by yourself to set up this equation. Go ahead. Yeah, go ahead. So, first of all, when you read the problem, you have to ask, how many parties are involved in this? We have Ryan, we have Castell, right? So I would definitely kind of structure it out so that I know who's involved. Here's Ryan, and here's Castell. We know they're going to be working together. And at the end, we know they're going to be some kind of time working together. At least we have a structure down. So this is the together part. Okay, so let's take a look. For Ryan, how long will it take Ryan to do it? 5 hours. So one task for 5 hours. One task, 5 hours. Okay, because that's what it says. Digging just one hole, right? And Castell, one task, 6 hours, and you know you're going to be adding them together. And we'll ask how long it will take them to work on that same exact task, right? So it's just one task for X hours, which we don't know at this point. Now, I'm still sensing that people are still struggling with LCD. Remember I told you just do it 2 at a time. Don't try to do all 3, but we are trying to find the LCD for all 3 terms here. We have 3, so let's find 3, but let's take a look at this 5 and 6. What is the LCD for 5 and 6? 30, right? So if you know that's 30, then you can bring up the other denominator down, and then do it again. 30 and x, what is the LCD then? 30x, you see it?
That's right.
So, once you have that, you are going to be multiplying that to every single term. Not just the left, not just the right. Every single term. So 30x, 30x, 30x. So let's start our cancellation process here. What is 30x divided by 5? 6x. 6x times 1? 6x, right? And over here? 5x. And over here? Just 30. So what is 6x plus 5x? So we have 11x equals to 30. And we divide by 11, both sides. X is approximately, just going to round it, about, roughly, it's a bit less, right? But roughly about 3 hours. Which kind of makes sense. That's fine, but I'm saying you can certainly estimate, and that's fine with me. And you want to get an exact answer as you can. Oh, roughly.
I got 2.7.
Yeah. If you round it, if you round it,
Me too.
right? Okay.
No.
Any question on this problem? Now, I want you to go and think hard for this upcoming problem right here. It takes a bit more work, but Oh wow.
I don't think it's working.
Whoa.
Dude, it's not erasing at all. Use the little arrow.
That's fine. Don't worry about it. We'll take care of it. Oh, here we go. A roofer can shingle a house in 20 hours. An apprentice helps. They can do the job in 12 hours.
We're talking about
How long does it take the apprentice to do it alone?
Probably.
So,
division.
okay, good. Give me an estimate now. How long do you think the apprentice to do it alone?
Probably like,
And a
yeah.
shingle.
You know.
What's a shingle?
Yes.
Oh, I know. I think I
Does it mean single?
No, shingle.
No, shingle.
Shingle?
Shingle, shingle,
Doesn't build?
Yes, yes. Okay, so think about that. How long did it take them to shingle the house?
About 6, 7 hours. I don't know.
The roofer by himself can do it in 20 hours. That's a professional talk about. An apprentice, like a trainee, helps, of course. If that trainee helps, it cuts down the time to 12 hours. Now my questions is, notice I kind of asked you a different question this time. Instead of asking how long it'll take them to work together, we already have the time together,
Are we
right?
dividing it?
I think I know.
We already have the time together. I'm asking how long will it take the trainee or the apprentice here to work by himself or herself. Now, think about this. What kind of answer do you expect to have for the apprentice?
Bigger.
Bigger than what?
20.
Exactly. Because if the professional can do it in 20 hours, the trainee by himself should take a lot longer time, right?
30 or 40.
So at least we know that the time we expect to get that should be bigger than 20 hours. But the question now is, how do we actually set this up? So let's start. What do we need to declare? Okay, what is this X representing this time?
The apprentice.
Okay, time for the apprentice, right? Whoa. Okay, so time for the apprentice. So let's go ahead and lay it out. Here is the professional, the roofer himself. Here is the trainee. And of course, this is together. See, I'm still using the same exact structure like always. I'm not changing it. But now, all that you need to do is figure out what's already given to you. So what's already given?
The roofer.
The roofer. What can you say about the roofer?
120.
Very good. What can you say about the trainee?
1 over X.
This time, because I declare X to be the trainee's time, that means for that same task, we just don't know how long it would take the trainee to do it, right? Do we know about them together?
1 over 12.
1 over 12.
Also, we're doing
See how it takes a little bit, the position of your variable is a bit different this time. However, it is still the same structure. Can you now find your variable? Go ahead, find it. Solve it.
60.
What's your LCD?
60.
Okay, fine. You said 60x, so let's go ahead and use that. 60x.
So why is it 60?
Oh, let's take a look. Very good.
Oh.
Why is it 60? First of all, let's take a look at 20 and 12. What is the LCD for 20 and 12? 60, isn't it?
Yeah.
No. Okay, why? That's okay. That's okay. Let me show you. 20 and 12. If you do the ladder on it, what can you take out?
4.
4. If you take out 4, what do you have left?
5 and
5 and 3.
I'm trying to learn.
Is that right?
Yeah.
Can you take anything out for 5 and 3?
No.
No. So that means it's a 1, right?
No.
So if you say no, you're done. Then you just have to multiply everything up. 4 times 5 is 20. 20 times 3, 60. That's how I got it. And of course, I do not forget about the x term, right? So that will be part of my LCD as well. So 60x is your LCD. So let's start our cancellation process. What will this get us? 3x, because 60 divided by 20 is 3, right?
30.
Next one, 60. And this one, 5x. Okay, what do we need to do here? Move the 3x, okay, so I'm going to go ahead and subtract the 3x over. That will give us 60 equals to 2x, and divided by 2, x is 30 hours. Now, does that make sense for the trainee to take 30 hours? Yeah, perfect sense. Because the roofer took 20 hours to do it, then the trainee should be longer, and there it is, 30 hours. Any question on this one? So this next problem, though, I really want you to think hard, okay? I know it's a bit challenging this time, but here it is. Read it carefully. Let's take a look here. We still set up the same way. We read the question, we read the problem, it's asking how long would it take to fill the pool if only the slower pipe is used. That means we need to find the time for the slower pipe. So if you were to do this, don't you need to declare X to be the time of the slower pipe? Okay? Write that down, guys. You need to. Okay? So X is the time the slower pipe takes to fill up the pool. Then we start setting up our structure. How many parties are involved? In this case, we have the slower pipe, we have the faster pipe. Here's the slower pipe. Here's a faster pipe.
The slower one has to go back first.
And of course, we have the together scenario. Okay, see it? I'm still setting up the same exact way. One party working together with another party, and of course, I have the together time. You see it? So let's take a look at what we have here. It says that one pipe can fill a pool 1.25 times faster than the second pipe. So that we know that's a faster pipe. When both pipes are open, they fill the pool in 5 hours. When both pipes are open, it means they're working together, right? Working together means right here on this side. Working together to fill one pool, one task, takes 5 hours for that. Did you get that part?
No.
Okay. No?
I do. Thanks.
Look at it.
It takes 5 hours.
Takes 5 hours to fill the same pool together. I just got that information from the problem. You see it?
Like, wait, huh?
Okay. Now let's go back. For the slower pipe to fill up that same pool, what did we declare for the slower pipe? Just X. Is that correct?
Yes.
It takes X number of hours to fill up that same pool for the slower pipe. Watch what happens to this fast pipe. We want to fill that same pool, but we do not know exactly, because other problems I actually give you the number of hours or the number of minutes or whatever to do it. But here, instead of giving you the exact time, I just gave you this. The faster pipe is how much faster? 1.25 times faster. So, for those of you who just put it like this, not quite. Let me tell you why. I want you to go ahead and use the scenario. X right here represents the time for the slower pipe, right? Now let's think about this. Let's say that the slower pipe takes, or maybe the slower pipe takes 10 hours. I'm actually giving you an actual value that you can actually play with. If the slower pipe takes 10 hours to fill the pool, and the faster pipe, let's change the number a little bit so it makes it easier for you to see. The faster pipe can do it 2 times faster. Then how long will it take the faster pipe to fill up that same pool? How do you do it? Divide. So don't you take the time of the slower pipe divided by 2? Is that true? To find out how the time for the faster pipe. Is that correct? So instead of that, instead of giving you an actual value, I gave you just X. So what should go in here? Very good. X divided by 1.25. Okay, let's go back again. Pretend that X is the number of hours, and I said, okay, the slower pipe takes 10 hours to do it. X takes 10 hours. I'm just giving you a scenario right now. And that the faster pipe can do it, instead of using 1.25, I said 2 times. Let's say that. 2 times faster. Then how long will it take the faster pipe to do it? How do you do it? Once again, don't you have to take X divided by 2?
Yes.
Which is 10 divided by 2?
Yes.
So let's go back to our actual case. It's, instead of having it 2 times, it's 1.25. Then should it be X divided by 1.25? That's what I mean.
Oh.
Okay, so that's a little tricky, and you know, sometimes you really need to see this several times to see it. But there, that's what we have right now. Okay, what do we do when we have a fraction divided by a fraction?
Solve it.
Fraction divided by fraction, what do we do? Flip what? The second fraction. And turn it into a what?
Close enough.
What is it? Okay, turn it into a multiplication problem, so reciprocal, right? Okay, so is this what you have now? If you flip this, is it 1.25 going to be on top? Is that correct? And the x is going to be on the bottom? True? Okay, and now this is our problem. Let's find the LCD. What's the LCD?
Okay, but like, I put the fast pipe first and then the slow pipe.
That's fine, doesn't matter. Okay, what's the LCD? 5x. So 5x, 5x, and 5x. There it is. What's the, what do we cross cancel? What do we have now? 5. Next. What is x cancel? What's 5 times 1.25? 6.25. Okay. And of course, what is 5x divided by 5? X, so x times 1? Oh, interestingly enough, we don't have to solve much except for adding this. So what is it going to become? 11.25 what? Hours. So, what are we learning here? We learned that for the slower pipe to fill up this full, it will take it 11.25 hours to do it. And we can certainly do the faster pipe too. We just have to take it back and plug it back to x here divided by 1.25, and we have the time for this faster pipe.
Well, we have to do that.
Well, since I'm only asking you for the slower pipe, you don't have to. But if I ask this question, oh, so how fast is the fastest pipe can fill up the full, then you have to do it. Plug it back in to solve. But this is it. X represents time for the slower pipe. Okay. Any questions on this? Okay. If no further question, we'll just call it a day here.